Hello friends, in our daily life we use magnets in many things, and today we'll see the types of magnets and their properties. Generally magnets are of two kinds, temporary magnets and permanent magnets. Temporary magnets are made up from iron, cobalt and nickel, but they have their magnetic properties for a short period of time. But permanent magnets are made up from the mixture of iron, cobalt and nickel, and they retain their magnetic properties for a long time. Today we'll see the different types of magnets and their properties. Let's begin. Here we see some objects placed on the table, and we are going to study which are magnetic and which are non-magnetic. For this I am using this disc shaped magnet. Now this is an aluminum rod, a wooden pencil, a glass rod and a plastic scale, but these all haven't got stuck to this magnet, means these are non-magnetic substances. Here we see a coin has got stuck, this iron rod and nail also have got stuck, means substances which have got stuck to this magnet, these are magnetic substances, and these other are non-magnetic substances. Let's see different shapes of magnets. This is a disc magnet, this is a cylindrical magnet, a ring shaped magnet, a bar magnet. Let's keep this ring magnet to side, and this one is a horseshoe magnet. Thus we see different shapes of magnets, and today we are going to study the properties of magnets. Before this, I'll show you a magnetic compass which is used for fixing directions. Now it's circular in shape, and you can see it has a white disc, and on its white disc you see directions are written, north, south, east and west directions, and there is a magnetic needle which is freely suspended, and on this needle there is a red mark. For fixing directions, we'll rotate this compass a little bit and we'll know the directions. See, we are matching it, and after some time we will see here north, south and east, west, all directions are fixed, and using these directions we'll study next property of the magnets. For this I have tied a bar magnet to a stand with the help of a thread. See, in the middle I have tied a thread to this bar magnet and upper end to the stand. Now I'll rotate this magnet to see when a magnet is suspended in air in which directions it rests. See, the bar magnet is rotating around itself. After some time, the magnet gets rested in specific directions. Both poles show north and south directions. See here, north and south, means a freely suspended magnet always rests in north south directions. After this we'll study another property. For this we'll use these horseshoe magnets. They do have poles north and south, and now we'll bring them close to see what happens when I bring opposite poles. See, these opposite poles have attractions, so they have got stuck to each other, and now I'll interchange the poles, means I'll bring like poles together. Now see what happens when I bring like poles together. See, like poles repel each other. See, this is how they repel, means when we bring unlike poles together they attract and like poles repel. thus it's proved. And another property, now this is also a bar magnet and it has north and south poles. Here we want to see when we break the magnets, their poles don't get separated, they appear in pairs. See here, there are two pieces of magnets, but even after breaking, you see here south and north pole is created here. Here north and south poles are created, means even after we break magnets, their poles don't get separated, they appear in pairs. And we can uh, see with the help of attraction and repulsion property that we have already studied before this. And after this we'll study another property, and for this we'll use this iron powder and a bar magnet and a plastic bag. I'll wrap this bar magnet in this plastic bag so that the iron powder doesn't get stick to this magnet, so it will be difficult to remove. So I am wrapping this in a plastic bag, polythene bag. And now we're going to study whether the whole portion has the equal magnetic force. For this I am running this bar magnet in this iron powder. See on which portions this powder gets stuck. See, on the poles we see large quantity of iron powder has got stuck, means the power of magnet or the magnetic force is strongest at the poles. Thus we have seen using this bar magnet that magnetic forces are strongest at the north and south poles of a magnet. And the last one we'll see temporary magnetism. For this I'll use an iron nail and some pins of iron and a magnet. Let's see. No, these pins don't get attracted to this iron nail. Now I'll rub this cylindrical magnet on this nail from one end to the other for 7 to 8 times, and we'll see whether this nail becomes a temporary magnet or not. After rubbing, I'll bring this nail towards these pins and see these nails are hanging to the nail, means they have got stuck to the nails, and now this nail is a temporary magnet. Let's meet in another video with innovative experiments.